Hello everyone, hope you are doing great. I am Bashar. Welcome to my channel Tech Quest Learning Point. I am continuously discussing on the Microsoft Azure Data fundamentals. In my last episode, I discussed on the data roles and services. Today I am going to discuss on the fundamental relational data concepts. This tutorial is derived from Microsoft Learning Path that help you to make preparation of the exam DP900 Microsoft Azure Data Fundamentals certification. So I can assure you that this tutorial will be helpful to clear the exam DP900. Before starting the tutorial, let's see the content of this tutorial at a glance. Relational database systems are a common way to store and manage transactional and analytical data in organizations of any size around the world. In this tutorial, you will learn about the key characteristics of relational databases and explore relational data structures. This tutorial covers the various topics related to the fundamental relational data concepts, including characteristics of relational data, normalization, types of SQL statement, and common relational database objects. A relational database is a collection of information that organizes data in predefined relationships where data is stored in one or more tables or relations of columns and rows, making it easy to see and understand how different data structures relate to each other. Relationships are a logical connection between different tables established on the basis of interaction among these tables. In a relationship database, collections of entities from the real world are arranged as tables. An entity can be anything for which you want to record information, typically important objects and events. In a retail system, different tables for customers, products, orders, and line items are created within an order. A table contains rows and each row represents a single instance of any entity. In the retail system, each row in the customer table contains the data for a single customer. Each row in the product table defines a single product. Each row in the order table represents an order made by a customer, and each row in the line item table represents a product that was included in an order. So it clear that relational tables are a format for structured data, and each row in a table has same columns. Though in some cases not all columns need to have a value. For example, a customer table might include a middle name column, which can be empty or null for rows that represent customers with no middle name or whose middle name is unknown. Each column stores data of a specific data type. For example, an email column in a customer table would likely be defined to store character-based text data which might be fixed or variable in length. A price column in a product table might be defined to store decimal numeric data, while a quantity column in an order table might be constrained to integer numeric values. These are standard data types defined by a American National Standard Institute (ANSI) that are supported by most database systems. In order to develop the clean data, data normalization is generally considered. Normalization is a term used by database professionals for a schema design process that minimizes data duplication and enforces data integrity. So we can say the normalization is a database design technique that reduces data redundancy and eliminates undesirable characteristics. For data normalization, the following points are noted. Data normalization is the organization of data to appear similar across all records and fields. It increases the cohesion of entry types, leading to cleansing, lead generation, segmentation, and higher quality data. While there are many complex rules that define the process of refactoring data into various levels or forms of normalization, a simple definition for practical purposes is: separate each entity into its own table, separate each discrete attribute into its own column, uniquely identify each entity instance row using a primary key, use foreign key columns to link related entities. To understand the core principles of normalization, suppose the following table presents a spreadsheet that a company uses to track its sales. Notice that customer and product details are duplicated for each individual item sold, and that the customer name and postal address and the product name and price are combined in the same spreadsheet called sales. Now let's look at the normalization changes the way data is stored. Each entity that is represented in the data, customer, product, sales order, and line item, is stored in its own table, and each discrete attribute of those entities is in its own column. Recording each instance of an entity as a row in an entity-specific table removes duplication of data. For example, to change a customer's address, you need only modify the value in a single row. The decomposition of attributes into individual columns ensures that each value is constrained to an appropriate data type. For example, product prices must be decimal values, while line item quantities must be integer numbers. Additionally, the creation of individual columns provides a useful level of granularity in the data for everything. For querying, for example, you can easily filter customers to those who live in a specific city. SQL stands for Structured Query Language and is used to communicate with a relational database. It's the standard languages for relational database management systems. SQL statements are used to perform tasks such as update database or retrieve data from a database. In a simply, SQL is a programming language which is used to update and retrieve data to and from a relational database system. By using SQL, we can perform the tasks including data create, retrieve, update, and delete, that is CRUD operation. Here is some common relational database management system that use SQL include Microsoft SQL Server, MySQL, PostgreSQL, MariaDB, Oracle. SQL was originally standardized by the American National Standard Institute (ANSI) in 1986 and by the International Organization of Standardization (ISO) in 1987. Since then, the standard has been extended several times as relational database vendors have added new features to their systems. Additionally, most database vendors include their own proprietary extensions that are not part of the standard, which has resulted in a variety of dialects of SQL. The ANSI and ISO has standardized some SQL statements which is used to accomplish almost everything that you need to do with the database. Although these SQL statements are part of the SQL standard, many database management systems also have their own additional proprietary extensions to handle the specific of that database management system. The standard SQL statements include select, insert, update, delete, create, drop. Microsoft SQL Server and Azure Database services that are based on the SQL Server database engine use Transact SQL. This implementation includes proprietary extensions for writing stored procedures and triggers, application code that can be stored in the database, and managing user accounts. PostgreSQL and MySQL also have their own versions of these features. SQL statements are grouped into three main logical groups: Data Definition Language (DDL), Data Control Language (DCL), Data Manipulation Language (DML). DDL statements. You use DDL statements to create, modify, and remove tables and other objects in a database, table, stored procedures, views, and so on. The most common DDL statements are create. Create a new objects in the database such as table or a view. Alter. Modify the structure of an object, for instance altering a table to add a new column. Drop. Remove an object from the database. Rename. Rename an existing object. Look into the code snippet. It creates a new database table. The items between the parentheses specify the details of each column, including the name, the data type, whether the column must always contain a value, not null, and whether the data in the column is used to uniquely identify a row primary key. Each table should have a primary key, although SQL does not enforce this rule. The data types available for columns in a table will vary between database management systems. However, most database management systems support numeric types such as int, an integer or whole number, decimal, a decimal number, and string types such as varchar. Varchar stands for variable length character data. For more information, see the documentation for your selected database management system. DCL Statements. Database administrators generally use DCL statements to manage access to objects in a database by granting, denying, or revoking permissions to specific users or groups. The three main DCL statements are grant permissions to perform specific actions, deny permissions to perform specific actions, remove a previously granted permission. Look into the code snippet. The following grant statement permits a user named user1 to read, insert, and modify data in the product table. DML statements. You use DML statements to manipulate the rows in tables. These statements enable you to retrieve, query, data, insert new rows, or modify existing rows. You can also delete rows if you don't need them anymore. The four main DML statements: select, read rows from a table; insert new rows into a table; update, modify data in existing rows; delete existing rows. The basic form of an insert statement will insert one row at a time. By default, the select, update, and delete statements are applied to every row in a table. You usually apply a where clause with these statements to specify criteria. Only rows that match these criteria will be selected, updated, or deleted. Look into the code snippet. The following code is an example of a SQL statement. Selects all columns indicated by asterisk mark from the customer table where the city column value is settled. In order to customize data organization, encapsulate programmatic actions, and improve the speed of access, we can use some database structures other than the database table. These three structures are views, stored procedures, indexes. View. A view is a virtual table based on the results of a select query. You can think of a view as a window on specified rows in one or more underlying tables. For example, you could create a view on the order and customer tables that retrieves order and customer data to provide a single object that makes it easy to determine delivery addresses for orders. You can query the view and filter the data in much the same way as a table. The following query finds details of orders for customers who live in Seattle. Stored procedure. A stored procedure defines SQL statements that can be run on command. Stored procedures are used to encapsulate programmatic logic in a database for actions that applications need to perform when working with data. You can define a stored procedure with parameters to create a flexible solution for common actions that might need to be applied to data based on a specific key or criteria. Look into code snippet. The following stored procedure could be defined to change the name of a product based on the specified product ID. When a product must be renamed, you can execute the stored procedure passing the ID of the product and the new name to be assigned. Index. A database index is a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage space to maintain the index data structure. An index helps you search for a data in a table. Think of an index over a table like an index at the back of a book. A book index contains a stored set of references with the pages on which each reference occurs. When you want to find a reference to an item in the book, you look it up through the index. You can use the page numbers in the index to go directly to the correct pages in the book. Without an index, you might have to read through the entire book to find the references you are looking for. When you create an index in a database, you specify a column from the table, and in the index contains a copy of this data in a stored order with pointers to the corresponding rows in the table. When the user runs a query that specifies this column in the where clause, the database management system can use this index to fetch the data more quickly than if it had to scan through the entire table row by row. Look into the code snippet. You could use the following code to create an index on the name column of product table. The index creates a tree-based structure that the database system's query optimizer can use to quickly find rows in the product table based on the specified name. Review. Relational database. A relational database is a collection of information that organizes data in a predefined relationships where data is stored in one or more tables or relations of the columns and rows. Normalization. Normalization is a database design technique that reduces data redundancy and eliminates undesirable characteristics. SQL. SQL stands for Structured Query Language and is used to communicate with a relational database. It's the standard language for relational database management systems. SQL statements. The ANSI and ISO has standardized some SQL statements which is used to accomplish almost everything that you need to do with a database. The standard SQL statements include select, insert, update, delete, create, and drop. DDL statements. You use DDL data definition language statements to create, modify, and remove tables and other objects in a database table, stored procedures, views, and so on. DCL statements. Database administrators generally use DCL data control language statements to manage access to objects in a database by granting, denying, or revoking permissions to specific users or groups. DML statements. You use DML data manipulation language statements to manipulate the rows in tables. These statements enable you to retrieve query data, insert new rows, or modify existing rows. View. A view is a virtual table based on the results of a select query. You can think of a view as a window on specified rows in one or more underlying tables. Stored procedure. A stored procedure defines SQL statements that can be run on command. Stored procedures are used to encapsulate programmatic logic in a database for actions that applications need to perform when working with data. Index. A database index is a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage space to maintain the index data structure. Thank you for watching this tutorial. I hope you all have been able to take the idea about the fundamental relational data concepts. If you think this tutorial is helpful for learning the Azure Data Fundamentals, please click on like button and request you all to share it more and more to the persons who are searching the tutorial like this. If you have any questions on this tutorial, opinions and queries about this channel, please type this in the comment box. You also mail to me. In the description box, email ID is given for you. Kindly subscribe this channel and click on the bell button so that you can get notification when new tutorial is published.